Okay, IBAASL2. Today we're going to talk about yet another derivative rule. This one's called the quotient rule. I don't know if you remember that word quotient, but it means that when you're dividing two things. So, straight up, the quotient rule of derivatives. If you have a function over a function, maybe we should do different colors just to be festive. Then the derivative of that function is the bottom function times the derivative of the top function. So here's the top. Notice that is the derivative, u prime x, minus the top function, just regular top function, times the derivative of the bottom function, all over the bottom function squared. So, I realize that's slightly confusing to be like derivative of this one, that one, whatever. So we've come up with this handy dandy way to remember this, which is low d high minus high d low over low squared. So let's see if we can break that down. Low d high. If you look like this is the high function on the top, and this is the low function on the bottom. Low d high, like this right here, is low function all on its own, and then this is derivative of the high. Same with this is high function all on like original, no derivative, and then times d low, and then this is low squared. So low d high minus high d low over low squared. Let's take it for a test drive. So we're going to differentiate y equals x squared minus 3 over 3x minus x squared. Remember that to find the derivative, it's going to be low d high minus high d low over low squared. So we're going to have a big fraction. And then we do low d high. So this is low. This is high. The low on its own is 3x minus x squared. And then times x squared minus 3. Or no, sorry, low d high. So we take the derivative of the high, which is 2x. And then, low d high minus high d low, so minus. And then the high all on its own is x squared minus 3. And then the d low, remember, it's just the power rule of down here. So that's like 3 minus 2x. And then all over low squared. So the whole thing is just the low part, and then you square it. So we like that is the derivative, but let's see how much we have to clean it up. I think we can do a lot of cleanup here in the top. We don't necessarily have to FOIL out the bottom down here. It's kind of like, I don't know, it depends on what your goal is. Like, you know, if it's to have a completely simplified function, then yeah, you might want to FOIL out the bottom. But if the goal is to like find the slope of a tangent or something like that, then you don't really need to FOIL out the bottom. But I do want to simplify the top. If I distribute here and here, I get 6x squared minus 2x to the third. Then I am going to FOIL these two and leave that minus on the outside. So we're going to do minus, and then whatever that would be FOILed out. So that would be 3x squared minus 6x cubed. Inner would be minus 9, and then last would be plus 6x. And this is still over 3x minus x squared squared. Now, I would like to take this negative and distribute it to all 4 of those terms. So I'll just let the 6x squared, big fraction, 6x squared minus 2x cubed hang out. Then we'll do minus 3x squared plus 6x cubed plus 9 minus 6x. Make sure I flipped all the signs. Yes, I did. And then we're still over 3x minus x squared squared. And then up top, we just got to do any apples and oranges we can. So let's see. I see an x squared and an x squared here. Well, let's do the cubes first, actually. We'll go in descending order. Negative 2x cubed, positive 6x cubed is 4x cubed. And then the squareds will be plus 3x squared. And then the 9 and the negative 6x don't have any buddies, so it'll be minus 6x plus 9. And the book doesn't seem to think that we need to FOIL at the bottom, so let's just leave it. Hold up, did I do something wrong? Maybe the book did. 3x minus. I forgot. No, I didn't. 6x squared minus 2x, 3x squared minus 6x plus 9. They seem to think that the cubes canceled out. Did I miss? That would mean that that would be negative 6x cubed. I think that's positive 6x cubed. All right, I think the book may have had a problem there. I think that's the derivative. But at any rate,